Today on Building the Open Metaverse.
Within Unity is that some of the teams actually do very good work and very useful work and very amazing work, and almost no one except themselves know what they're doing.
Welcome to Building the Open Metaverse, where technology experts discuss how the community is building the open metaverse together. Hosted by Patrick Cozy and Mark Petit.
Hello and welcome back, Metaverse builders, dreamers, and pioneers. I'm Mark Petit, and this is my co-host Patrick Cozy.
Hey Mark, great to be here. I really love the technical episodes. We're in for a treat today.
You're listening to Building the Open Metaverse Season 5. This podcast is your portal into open virtual world and spatial computing. It brings you the people and the projects that are on the front lines of building the immersive internet of the future, the open and interoperable metaverse for all.
And today we have a special guest joining us on that mission, Aras P. He's an expert in software and game engine architecture. I believe he was employee number 4 at Unity, having worked there 2006, 2021. He's done so many articles and open source projects on software architecture, rendering, game engines, file formats. I personally, Aras, have learned so much from you over the years. I think I've been following you on social media since 2009. Nowadays, I see you're doing great work contributing to Blender, and we're very inspired by your article and examples on Gaussian splatting. And I think we first met probably in 2010 when Kevin Ring and I were working on the Virtual Globe book, 3D engine design for Virtual Globe, and we asked you to review some of it. So I wanted to thank you again for doing that and joining us on the podcast. We like to kick things off by asking folks to describe their career journey.
I started doing something with computer graphics in the previous millennium, around 95 or something. Of course, sort of just as a hobbyist and so on and so forth. And then I was shortly involved in the European demo scene and a few small game development studios that no one has heard about because we didn't really ship anything notable. In some cases, didn't ship anything at all. But then some things led to other things, and I joined Unity in 2006, back when Unity was a product that basically no one has heard about, and we were just a tiny startup, sort of trying to make a fairly simple game engine. Back then it was Mac only, of all things, and Mac was not a popular platform at all. Back then, it was iPhone didn't exist. Macs were still on PowerPC architecture. I worked at Unity for 16 years. I left Unity about in late 2021, and I've been doing sort of random projects since then. So basically, that's my journey. And I remember we met Patrick, I think it was GDC, maybe 2010 or 2000 something. My memory of that is that you were asking opinions about what became GLTF 1. And I was like, yeah, this makes sense, but there's pretty much zero chance to make a new file format. And here we are.
So Aras, I think we're all curious. I mean, Unity is an impressive trajectory, and you've been their employee number 4 in the early days. So can you share with us some of the most vivid memories of the early days?
A lot of these memories are sort of hazy at this point. And I do remember that we sort of a typical startup life, back when we were just a handful of people, everyone was doing sort of everything. I do remember that the CEO at the time, David Helgason, used to cook lunch for us and clean the office because we couldn't afford cleaners. I was the one fixing the website on Internet Explorer 6 because I was the one with a Windows PC. Everyone else used Macs, so this is kind of, fun times of wearing many hats. For example, I was originally hired as a graphics programmer, and then eventually I made the web browser plugin back when web browser plugins existed, and I was one of the 2 people to port the Unity editor to Windows, because as I mentioned, initially it was Mac only, and there was a lot of work to actually rip out all the Mac specific stuff and replace that with something that is multi-platform. And of course, once we added Windows editor support, then sort of all the floodgates of Windows users opened and Unity kind of grew in popularity. And then the other growth was when we added iPhone support at the very start of the mobile gaming sort of, I guess, revolution, you could say.
I want to switch over to a different topic, which is soft skills. And I know you were involved in mentoring young programmers at Unity, and you said something interesting that, learning to program on a team can be challenging. For us as engineers, we have to learn how to collaborate and communicate effectively. I think you said something like that, a skill that is not taught in the university. So do you think that is still the case now?
It's very rare that you're working on some problem just by yourself, especially at modern scale of software complexity. It's very nice if you like working on something yourself and you can work on something solo. I mean, there are products and complete even games made by just 1 or 2 people, right? Something that is not communication per se, but what I've seen, for example, within Unity is that some of the teams actually do very good work and very useful work and very amazing work, and almost no one except themselves know what they're doing. So this is not so much communication, but more like marketing almost, so to speak, in terms of if you're doing something important or something that is just cool, some people, for some reason, don't really know how to tell others or potentially interested parties or your users or your customers about it. And I've seen that over many products, mostly within Unity, because that's majority of my work experience. But where, for example, Unity as an engine technology company would do something that is actually very useful and very cool, and almost not tell anyone about it. So it's kind of, we have a GPU-driven rendering now, which is fairly sort of recent for Unity, and it's hidden in one forum thread post on Unity forums somewhere.
I'm going back 10 or 15 years, but when I was teaching at University of Pennsylvania, I remember when the graphics program actually moved from Gamebryo to Unity. And I think the students, they both liked Unity, the engine, and they liked programming in C#. So I wanted to ask you a bit about, what you think the future of scripting or creation is, whether, there's C#, there's Blueprint and Unreal, there's Lua and Roblox, and Roblox is also doing like some AI assist for creating materials and coding. Kind of like, how do you see that playing out?
It will change things drastically somehow once the dust settles, right? And with all big changes, it usually takes a decade for the dust to settle, for the workflows to actually emerge, and for the sort of the right products and the right technologies to emerge. So we're probably in the middle of that with AI. Now, whether programming should be sort of text-based or node-based or some other type of paradigm, I don't know. On the other hand, I know a lot of sort of technical artists and other people who are more visual than I am, I guess, where they are exactly the opposite. They understand nodes, they don't understand text-based code. So it probably depends on the type of person, plus their experience or their education. Some of the things, nodes are obviously more preferred way of expressing intent, something that's sort of more high level, or especially if it has timing components, so more like if this door opens, then place in whatever this VFX instance there, then after 3 seconds do this or that, and that's just sort of boring. And with AI, it seems that everyone is trying to do some sort of AI based tooling. Roblox has their thing. Unity just recently announced something called Sentis or Muse that will do something. It's pretty vague what exactly that will do, but they have some marketing material. And I'm pretty sure that every sort of large company is looking into that in one way or another.
Sweeney from Epic has chosen to go a different route and to create a new language from scratch.
Right.
To cater to the specifics of the metaverse. And so it's a double-edged sword argument, but you have LLMs. So, it's going to be easier to learn a new language, or you create a new language where, you can use LLM to program. What do you think about that?
I would say that making a new programming language and have it be successful has almost zero chance of succeeding. But I said the same about GLTF to Patrick, right? So probably I'm not a good predictor.
Aras, maybe that's a good segue into one of our favorite topics, which is 3D file formats and open standards. And, we know you've done a ton of work there over the years, and recently you've really optimized the OBJ within Blender. So, would love to hear kind of how you're viewing the landscape today, looking at GLTF, USD, OBJ, PLY, just whatever's on your mind.
I was building a house, and I got a 3D model of the house from an architect, and I was like, I know 3D graphics. I'm gonna just throw this into Unity or into something else and do a visualization before it's built. Just because, why not, right? And I think I got a Collada file of all the things out of them. Remember Collada? It used to exist. And I think I tried to put that into Unity, and that didn't go very smoothly because it had like 500,000 objects or something like that. And 95% of that were individual planks around the fence, around the property, which has nothing to do with the house itself. And then I tried to put that into Blender, and after a while that was okay, and I don't remember how I ended up into OBJ land. Maybe I tried to export that into OBJ or something, and I noticed that it felt slow, and I started profiling, and Blender being open source, one thing led to another, and I ended up optimizing it a bit. Surprisingly enough, OBJ as a file format is one of these formats that shouldn't exist at this point, right? Because it was done in late 80s, I think, or early 90s. It doesn't actually have a specification. It has only like a README document that came with, I don't know whether that was even Maya or something before Maya. And similar to that, Stanford PLY still also exists. Probably also because of simplicity, and also because it has a really simple binary format where, if you have a 10 million vertex 3D scan, then OBJ is not any sort of purely text-based format is not the right call, and PLY has a binary format. So most of the 3D scanning community and Gaussian splatting community at this point uses PLY. Again, I guess because of simplicity.
So let's switch gear, because we want to talk about Gaussian splatting. We talked a lot about the past in GLTF, FBX, and even OBJ in the late 80s. Something incredible is happening with Gaussian splatting, I think. The research paper were published last summer, and we are now seeing commercial implementation of it. I know you've been contributing a lot of code to the community. So first, for our listeners, can you tell us what Gaussian splatting is?
I'd like to describe it as blobs in space. It's if you know a point cloud is a bunch of points in space, right? And some point clouds have every point also has a color or something like that. And if you take a lot of these points, you can describe a surface or a mesh or a scene with them. it would take a lot of points, right? Because a point is tiny. What Gaussian splatting is that every point is like a blob. It's a bunch of blobs that have scale and rotation in space. Now, every point also, and these are called sort of splats. And Gaussian just means it's a blobby shape. And each of these splats also has a transparency and a color. And somewhat crucially, color can change depending on direction. And that's encoded using spherical harmonics, which is fairly standard sort of way of encoding directional value. There was this paper this summer at SIGGRAPH. I think it was published somewhere, or maybe made online shortly before SIGGRAPH somewhere, where they found a way of taking a bunch of photos or pictures of a real thing and then figuring out how to create 1 million or so of these Gaussian splats in space so that they kind of represent these photos when looked at from various angles. And the key insight from them was how to make a decently fast renderer for them that is also differentiable, whatever differentiable means, I don't exactly know, but that allows them to do like a stochastic gradient descent to do this training process of figuring out where the splat should be. The actual Gaussian splatting is not new. It's based on a paper from 2002 where it was called elliptical weighted average splatting. And they use exactly the same math, so sort of they project it onto screen in exactly the same way as that paper from 20 years ago. It's just seemingly everyone forgot about that idea until now. Now, it's not exactly that everyone forgot. There have been sort of implementations that use some sort of splats or particles or blobs in space to render things. Most famous in real time is probably Media Molecule Dreams for PlayStation, where they used a bunch of things. They used sign distance fields and voxels and splatting and probably something else to do their rendering, which is, fairly unique among real-time renderers.
NeRF was the big thing a few months ago. So can you tell us the difference? I think it's fundamentally different between NeRFs and Gaussian splat, but can we go through that quickly?
Well, I know that it's trying to solve the same problem, the same sort of thing that the Gaussian splatting is trying to solve, which at this point is basically how do you capture a real object into something that you can view from any angle and it looks kind of realistic. The way I understand it is NeRFs encode that information in some sort of, interconnected neuron layers where it's not intuitive to understand what exactly happens inside, except you get a pretty picture in the end, right? Which is probably, well, I'm not a machine learning expert, as you can tell. And some of the NeRF implementations, as far as I know, they're fairly slow to render in real time, or if they're fast enough to render in real time, then the quality is kind of not that good. And also, depending on the NeRF implementation, the data sizes are between fairly small but not good looking and very large and very slow. Now, Gaussian splatting is conceptually much easier to understand because there's no sort of magic anyway. It's just blobs in space. That's it. So, for example, what I've been playing around recently is some tooling within Unity to do rudimentary editing of them. So you can crop out things that you don't want. You can remove things because again, it's just points in space, right? So it's easy to understand. It's easy to manipulate. I've seen some people starting to do some VFX stuff where they apply some additional, deformations or additional sort of, change colors or change the textures of the splats to make them look like the scene is burning or whatever. With NeRFs, I think that's much harder to do because, again, the internal representation is something that is hard to reason about.
And for me, it's flabbergasting to see that we're talking about a research paper that was out weeks ago, and now you had an implementation, Luma has an implementation, Polycam has an implementation. People are actually using it today on their phones and in production. So it's amazing to witness that happening in real time. The size of it as well and optimizing, I mean, it's early days. So do you think we can optimize much further and make it a real viable production technique out of that?
I'm pretty sure that there's probably a ton of research done in like generic point cloud compression somewhere, but I don't know any of that. So I just sort of rolled with whatever I thought makes sense to me, which is partially actually inspired by Media Molecule Dreams, the way they encode their splats into non-infinite amount of memory. So the way I do compression is basically chop up the whole scene into very sort of small, spatially coherent chunks, and then quantize the data of the splats inside these chunks to as few bits as possible. If they're sort of spatially coherent, then I can get away with just spending whatever 10 bits per position and things like that. So for capturing individual objects, in sort of my approach, the final data size is between like 3 megabytes and 10 megabytes, which is sort of, I would imagine that's a reasonable size for use case when you want to actually view a single object. Like you could imagine on a web page in like e-commerce or whatever, when you have a real object and you just want to sort of look at it from various angles, and sort of under 10 megabytes is fine probably. For capturing whole scenes, I don't know. We'll see where that goes, I guess. But also within, say, games or something like that, I think a much larger problem with Gaussian splats and with NeRFs actually is that, in games, we want to change lighting conditions. When with these technologies, we just capture reality with the lighting as it is.
I'm glad you mentioned Dreams twice, because I think it's an underrated effort. It was very innovative. My interpretation that by the virtue of just being on the PlayStation, it did not see the pickup that it could have, but it's my personal opinion. But it was a fantastic platform to create content, way ahead of its time.
So Ross, we had one more topic for you, and that's the potential future of 3D on the web. I mean, over the last 12 years at Cesium, I think we've written about 500,000 lines of JavaScript code using WebGL. And then on the podcast here, Mark and I have hosted folks from the Google Chrome team, Ken Russell, Quarantine Wallace, Brandon Jones, my former student Kai, and they've done amazing work on WebGL and WebGPU and WebAssembly. So just curious about your perspective on 3D on the web and where it could go and will become, as advanced as what you see with the game engines today.
It's exciting to me to see WebGPU finally starting to become a thing because I mean, let's face it, WebGL was kind of getting fairly old. Like WebGL 2 is basically OpenGL ES 3, which is at least a decade old at this point. But WebGPU is for any practical purpose, you cannot use WebGPU just yet because the market penetration is just not there yet. And that will probably change in a year or two or three. I think within various niches, 3D on the web, it's obviously already here and it's here to stay, but sort of what's the future of it? I don't know. Actually, for this my own Gaussian splatting thing, I did this way of compressing them and whatever, and now I'm kind of thinking about, so which of the web Gaussian splat viewers should I try to put my compression into right now, or should I just make one from scratch?
So, Aras, we love to wrap up the episodes asking if you want to give a shout out to any person or organization.
I would probably like to do a shout out to Blender and the whole community around it. To me, that's one of the open source projects that seems to be doing most of the things right. Because let's face it, making an actual product fully open source is a very hard thing to do, and a hard thing to do correctly. And Blender, against all odds, is one of the success stories, I guess. Especially considering how actually old it is. Like, Blender codebase started in 94 or something. So yeah, and I get that it's still lacking in terms of being industry scale in a lot of aspects, but there is a reason why Maya is still the king within large productions. But Blender is sort of moving at fairly impressive speed.
Well, Aras, thank you so much for being with us today. Employee number 4 at Unity, depth of knowledge in graphics and a level of humility that is fine to see. Thank you so much for being with us today. And also a huge thank you to our ever-growing audience. You can reach us for feedback on our website, buildingtheopenmetaverse.org, as well, and subscribe to our LinkedIn page, our YouTube channel, and all the podcast platforms. So, Aras, thank you so much for being with us today. Patrick, thank you too. And we'll see you soon for another episode of Building the Open Metaverse. Thank you.